if you have something of the form 0 times infinity, we also don't know what that means, because it depends, is it approaching the 0 or the infinity faster? Which one wins? So sometimes this answer might be 0, sometimes it might be infinity, sometimes it might be something in the middle. In this case, our strategy is to write it as a quotient and use L'Hopital's. So if we have something like this, we want to try to rewrite it and then treat it like yesterday's problem. So our first example. The limit as x approaches 0 from the right of x times the natural log of x. So if I'm looking at this, x is just going to 0. The natural log of x, keep in mind if you need to, the natural log graph looks like this. So as you're approaching 0 from the right, it's going to negative infinity. So we can see, do we know for sure what this is going to go to then? No, it's an indeterminate form. Our strategy is to somehow write this as a quotient. We do that by dividing by the reciprocal on one of these. Okay, so we have two options. We could either write it as the natural log of x divided by 1 over x, or you can write it as x divided by 1 over the natural log of x. Do you guys see if you divide by that fraction it's the same? Which one would we rather have on the bottom, 1 over x or 1 over the natural log of x? The 1 over x would be much nicer, so let's do that. Okay, so when you put one of them in the denominator, you have to do its reciprocal. So now, let's see what this thing is going to. As we approach 0, the natural log of x is still going to negative infinity over 1 over 0. We're approaching from the right. So 1 over a smaller and smaller positive number is going to infinity. So it's currently negative infinity over infinity. So if it's infinity over infinity or 0 over 0, that's when we can do L'Hopital's. So I did ask you to please just write that LH over your equal sign so I know what you did. And then we do the derivative of the top and bottom. So the derivative of natural log of x is 1 over x. 1 over x, you could think of that's like x to the negative 1 power. So its derivative would be what? Negative x to the negative 2? Or negative 1 over x squared? Okay, I recommend cleaning this up before we try to evaluate that. We have a 1 over x, and negative x to the negative 2. If you bring that x to the top, the exponent would become positive, right? When you change floors, you change signs. So that's like a negative x squared. So if you multiply those, one of your x's cancel, and we just get a negative x. Can I plug in at this point then? Absolutely, and my answer is 0. Did I lose anybody on that algebra? I didn't necessarily show all my steps, but I can show more. So I've lost you. The second indeterminate form we're talking about today are indeterminate differences. So I would like to read about those as well. Can I have? So what this tells us is if we have an infinity minus infinity. Again, we don't know for sure what that is. We can't just say it is 0 because we don't know which one is increasing faster, and we could get a different answer in between there. So our strategy is always to try to write this as a quotient so we can do L'Hopital's. So we'll do things like getting a common denominator and trying to put them together in a fraction, or factoring something, and then that would give us an indeterminate product, and then like last one you could move one to the bottom. So we'll try some of those algebra strategies to rewrite this into something we can solve. Okay, everybody's favorite, trig functions. Okay, we are approaching pi over 2 from the left. Secant x minus tangent x. You guys have that little trig function page we did at the very beginning? We drew all the graphs.
I did.
Okay, pull that up. I think we did like the unit circle, and then on the back of it maybe we drew the graph. Is that right? Or these all kind of work together, but. Did we not draw the graphs?
Yeah,
Huh?
they're on the back of the
They are on the back. Okay. So, can I just borrow your
Yeah.
for a second? So when I look at secant, we are approaching pi over 2 from the left. So you're coming in from this direction. Where is your graph going? Infinity. Okay, then we had tangent. So on tangent, as you approach pi over 2 from the left, where's that one going? Infinity. So this is currently of the form infinity minus infinity. So that tells me, first of all, it's indeterminate. I can't get the answer yet. But I have to somehow rewrite this so I can use L'Hopital's. These things aren't written as a fraction, but how could I rewrite secant? 1 over cosine. Let's do that. Minus, how could we rewrite tangent? Sine x over cosine x. Now, those even have a common denominator, so I could put them together in one fraction, so it'd be 1 minus sine x over cosine x. Alright, let's see what we've got. So, sine of pi over 2, that's sine of 90 is 1, so 1 minus 1 is 0, over cosine of pi over 2 is 0. So it's currently 0 over 0, which tells me we need to do L'Hopital's. Alright, derivative of 1 minus sine x. And your cosine x. Over derivative of cosine x. And your sine x. Okay, those negatives cancel. Can we evaluate? What is the cosine of pi over 2? 0. What is the sine of pi over 2? 1. And 0 over 1 is 0. Is that one okay? I am going to skip over the powers for now. We're going to do that tomorrow. But I am going to jump and do some of these examples. I want to go to example 10. Alright. So I have the limit as x approaches of infinity of x times the natural log of x minus 1 over x plus 1. So if I want to evaluate this, if I plug in an infinity, we get infinity times, okay, this natural log, we're going to have to think a little more, aren't we? We can't just do infinity over infinity. Could I, just for the purpose of simplifying this part, remember, like on the last test, we would take it times 1 over x. So that would be like the natural log of 1 minus 1 over x over 1 plus 1 over x. So as x goes to infinity, you have the natural log of 1, which is 0. So this is currently infinity times 0. Do we know what that equals? No. It's a product. We want to somehow write this as a quotient. Which of those things would you rather move to the bottom? The x. I strongly recommend never trying to move the log to the bottom. Leave it alone, just move your x. When I move that x to the bottom, what does it become? 1 over x. Okay, if it helps you, 1 over x, you could also write that as x to the negative 1 power. Dropping it down changes the sign on the exponent, so whichever way you prefer to write it. Okay, so if we plug in, we know on the top it's still going to 0. On the bottom, 1 over infinity is going to 0. So now it's 0 over 0, which tells me alright, how am I going to do the derivative of that mess? Yeah, we are going to have to do the chain rule, aren't we? So a derivative of a log is 1 over the argument. And then we'd have to do times the derivative of the inside, which would be the quotient rule. So low, d high, minus high, d low, over low, squared. Over derivative of x to the negative 1 would be negative x to the negative 2. Definitely lots of cleaning up we need to do here. Okay. 1 over x minus 1, x plus 1. What could I do to that? Well, how would I write this so it's not like a fraction in a fraction? You know, it would become x plus 1 over x minus 1. Just what's the bottom one? Okay, over here, if I clean that up, that gives me x plus 1 minus x minus 1 over x plus 1 squared over, you could go ahead and move that to the top. If you need to see a little more, that's like negative 1 over x squared. Okay, we're working on cleaning this up. I could cancel one of these x plus 1's out. So then if I distribute this negative, positive x and negative x cancel, so I have 2 over, bless you, x minus 1 times x plus 1. To divide by that fraction, you multiply by the reciprocal. So I get the limit as x approaches infinity, negative 2x squared over, let's go ahead and FOIL, x squared minus 1. Okay. Have I lost anything? We've done a lot of algebra right there. If I plug in, what do I have? Negative 2 times infinity squared is infinity. Infinity squared minus 1 is infinity. So it's still infinity over infinity. Yes?
Where'd you get that 2 from?
Right here when I did the 1 plus the 1.
Oh, okay.
So what does that tell me? L'Hopital's again. That's going to be much nicer now because we just have a polynomial over a polynomial. Okay, so derivative of the top would be negative 4x. Derivative of the bottom is 2x. What could you do there? Negative 4x divided by 2x is negative 2. And the limit as x approaches infinity of negative 2 is negative 2. A lot of work there. But that one just kind of really illustrates there is no way we could have looked at the beginning problem, the infinity times 0, and known we were going to get negative 2 there. So you can't just look at those and make a guess. Alright. Let's try some more. Let's do example 11. Okay, if I were to plug in 1 over 0, will be going to infinity. Sine of 0 is 0, so that would also be going 1 over 0, so that's going to infinity. So infinity times, or infinity minus infinity, do we know what to do with that? No. What's our strategy then? We want a quotient so we can do L'Hopital's. If you have a fraction minus a fraction, what could we do? Common denominator. Okay, so this denominator is x, so it needs to be multiplied by sine x. This one has the sine x, so it's got to be multiplied by x. We have sine x minus x over x sine x. Okay. This one, as far as looking at this and knowing what it's going to, it's very difficult because as x goes to infinity, does sine equal any one number? Oh, that helps a lot. Thank you. Okay, so that's not so bad. So sine of 0 is 0, minus 0 is 0. On the bottom, 0 times 0 is 0. So we have a very straightforward 0 over 0, which means L'Hopital's. I don't know why he wanted to write infinity there. Okay, so derivative of sine is cosine x minus derivative of x is 1. what do I have to do for the derivative of the bottom? Product rule. Derivative of the first times the second plus the first derivative of the second. Okay. If you want to rewrite that, you certainly can. You don't have to. We have cosine x minus 1 over sine x plus x cosine x. So if I plug in a 0, cosine of 0 is 1, minus 1 is 0. On the bottom, sine of 0 is 0, plus 0 times 1. So 0 over 0. L'Hopital's again. So derivative of cosine, negative sine, minus 1 would go to a 0, so I can just drop that. On the bottom, derivative of sine is cosine. Then I have to do the product rule. Derivative of the first times the second plus the first derivative of the second. Combine like terms. Cosine x plus cosine x, so 2 cosine x minus x sine x. Okay, so on the top, negative sine of 0, that's the opposite of 0, which is just 0. On the bottom, 2 times cosine of 0 is 1, minus 0 times 0. So we get 0 over 2, which is 0. We finally got an answer. Question? Yes, ma'am. Or were you just stretching?
Yeah.
Okay. I'll take the question. One more. I know these are a lot uglier than the ones we were doing yesterday. Okay. So if I plug in infinity, infinity squared plus 3 times infinity is just infinity. Square root of infinity is still infinity. So this is infinity minus infinity. Indeterminate form, we have to somehow write this as a fraction. Is a common denominator really helpful here? No, because neither of those things are fractions. Can I factor out anything? No. What's a strategy we've used in the past when we had problems involving radicals? Multiply by the conjugate. So this is over 1. The conjugate would be radical x squared plus 3x plus x. And we're going to multiply that on top and bottom. So I get the limit as x approaches infinity. And I multiply those two, the radicals drop. Negative x and positive x is a negative x squared. X squared minus x squared cancels, so we have 3x over, that's supposed to be an x, not a 1. The square root of x squared plus 3x plus x. Okay, if I plug in, we have infinity over infinity. So we're going to have to do L'Hopital's. Now, there are other ways of doing this, like L'Hopital's is going to get us there. What have we done in the past on problems like this, too? You're doing it on the last test when you found asymptotes. 1 over the highest power of x. So that is certainly still an option. You know, looking at this one, if you don't want to do the derivative with that square root in there, you could certainly do 1 over the highest power of x, which in this case is just 1 over x. Do you guys think that might be a little nicer on this problem? Yeah, probably. Do you want to try that? So L'Hopital's would work. I'm just rewriting this to kind of show you what we're doing. So if we multiply by 1 over the highest power of x on top and bottom, 3x over x would just be a 3. Okay, now let's think about with this radical. We've done these, but it's been a little bit. X would be the same thing as the square root of x to the second. And x times 1 over x would be 1. Okay, so under that square root, I'm dividing by x squared, so we get 1 plus 3 over x. So now we have 3 over the square root, 1 plus 3 over infinity is going to 0. So we get 3 over 2. Would have got the same answer by doing L'Hopital's, but we would have ended up having to do L'Hopital's a couple times, and it would have gotten very ugly. So just don't forget your old strategies. Sometimes that's helpful. This is where I want to stop today. So what we have left in this section is the powers. So we'll talk about those tomorrow, and then we will take a day and kind of do a little bit of everything. So tomorrow we'll finish the content. Thursday we'll just review all of those different types together. The homework for today, I am not collecting tomorrow. We will add a few more problems tomorrow, and it will be due then on Thursday. Is that right? Okay, so all but the last problems are odd, so that you can kind of check yourself as you're going, make sure you're doing okay. Make sure, though, you have to back up your answer. And then tomorrow I'll give you about 4 more problems, and we'll turn them all in on